Hey, it's 10.3, and in 10.3 we talk about the product rule specifically. Now this one section is by itself for a reason, and that is because of simplify by factoring, which starts at number 4. But let's talk about the product rule first, and that is that anytime you take two square roots that are the same root, any two roots that are the same root, in this case they're square roots, and they're being multiplied, you get to multiply what's underneath together. Like so. Choop, choop, choop. Right? So that problem was there just to show you the product rule by example. Just multiply the stuff underneath, right? And for number 2 says, hey, here's a problem where there's 7 roots, but since they're both 7 roots, we get to multiply what's underneath together. It's still a 7 root, nothing happens to this number. But then we have 5 times 7 is 35. Then we have x to the 5th and x to the 1st become x to the 6th, because when we multiply, we add the exponents. And that's all they wanted you to do for that, right? So we're just multiplying the stuff underneath as long as the roots are the same. And it works for 16x over 9 times the square root of 9 over 16. In this case, when we multiply, we're multiplying fractions. So if you don't want to do it this way, if you want to cross cancel, that's great. But what I'm going to do is I'm going to multiply straight across because that's the rule. 16 times 9 is 160 minus 16, which is 144. X. And then 9 times 16 is also 144. And ooh, they cancel. So you're just left with the square root of x. Lovely, huh? Okay. Number 4. So when we talk about simplify by factoring, we're going in reverse of what we just did. So imagine you started with the square root of 21 and you were asked to simplify by factoring. Well, that's one way to do it. We just split it up into square root of 3 times square root of 7. We're just going backwards. Now in that case, there's only one choice. That's 3 times 7. Those are the only two factors for 21, besides 1 in itself. But for 72, there's other choices, right? Now, which one do I pick? Do I pick 2 and 36? Do I pick, does 3 go into it? Yep. 3 and 24? Wait. 6, 12, yeah, 24. Do I pick 4 and 18? Do I pick 6 and 12? Or do I pick 8 and 9? 7 doesn't work, but 8 and 9 does. And that's all of the different factor choices you have for 72. So which one do we pick? What you do is you pick the pair. I know this might be in your notes, but I'm going to write it again. Pick the pair with the biggest square. Hey, it rhymes. You can remember that, right? Pick the pair with the biggest square. And that's this pair, right? 36 is a perfect square. It's bigger than 9, which is another perfect square. And it's bigger than 4, which is another one. So you had 3 choices. These didn't have any squares at all, so they were just right out. But the one you want is the one with the biggest square, and that's 36. So what I'll do is I'll write this as square root of 36 and square root of 2. It doesn't matter the order, but I like putting the perfect square first, just because it's prettier. So that's what happens. 72 splits up into these two numbers, and then this guy can actually be taken the square root of, whereas 2 cannot. And that's simplified by factoring. We're just going in reverse. All right, so let's look at 5. 5 has an x in it, but since it's just a single x, we can't break him down. So we're just going to leave x underneath the radical. But 600 can break down. And what I'm going to do is I'm going to, first of all, see 600 and think, oh wait, 100 goes in that. 100's a perfect square. And that's the number I want to pick. 100 and then 6. But like I said, x stays underneath there. So I'm going to put it with the one that can't break down, 6. If you think about it, 6 breaks down into 2 and 3. What is this? Okay, just slide that. Okay. Okay. Sorry. So we have square root of 100 and square root of 6x. 6 doesn't break down. This one does. He becomes 10. And he stays 6x. Cool. Let's look at number 6. Square root of 96x squared y. Okay, so something we learned in 10.1 was that this guy can be broken down, but this guy cannot. All right, let's split them up. 96 square root of x squared and square root of y. Now this is a basic idea. This is a thing you can do for any of these problems, no matter how complicated it gets. Just split it up into numbers and letters. And then for the numbers, we can go back and do what we did here with 72. We can say, what goes into 96? Well, we got 2 and 48. Nope. We got 3 and 32. Nope. Neither of them are squares. We got 4 and 24. Is that right? Yes. That's got a perfect square. That's a good candidate. What about 5? No. What about 6? Heck yeah. 6 and 16. That's a bigger square. And then we go, what about 7? Nope. What about 8? What about 8? Oh yeah. 8 and 12, right? And then 9 doesn't work, 10 doesn't work, and then we're back to 12, basically. So, okay. So this doesn't have a perfect square. He's out. So of these two, we have 16 and 4, and I want the one with 16 in it because that's the bigger square. Pick the pair with the bigger square. So I'm going to write 16 first, and then I'm going to write square root of 6. And then I'll just go ahead and write x squared and y again. We're not dealing with them. So basically, I split up 96 is what I did. I split them all up, and then I split up 96 into these two. Now, anything that can be squared will get squared. So square root of 16 is 4. Square root of 6. Square root of x squared is x, but in absolute value. And that's from 10.1. You should look that up again. Okay, so now we're here, and this is an answer. If I wanted to, because 6 doesn't break down and y doesn't break down, so this is good. But I kind of want to put everything back together in a way that has all the outside stuff together, so like 4 absolute value of x, and then all the inside stuff under one house, 6 and y. And that's a much prettier answer. My computer. All right, here we go. Number 7. All right. So here's where we have just letters, and there's a trick to this I want to show you. So what you would do with what you know about simplify by factoring is you would split up x to the 8th into x squared times x squared times x squared times x squared, and then you would split up y to the 11th to y squared times 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 y to the 1st. And that's 2 plus 2 plus 2 plus 2 plus 2 plus 1. That makes 11. And that's 2 plus 2 plus 2 plus 2. That makes 8. So this is the idea. You don't have to do this every time. There's a quicker way to do it. But this is just what I'm saying. All of them have a square root. So all of them come out. X times x times x times x. And then times y times y times y times y times y. Except for this guy. He stays underneath because he didn't break down. And then we put them back together as x to the 4th. Y to the 5th, and then a square root of y. And that's the answer. And yes, you should have absolute values, but I'm not very particular about that. It's no big deal. Okay, so with this one, this is the answer, and this is how I got it. And I just wrote it all out in squares because we're dealing with a square root. And then I broke them all down, and then I counted how many I had for each letter and what was left over. That's a long way to do it, but that's one way. Another way to do it, oops, number 8, is by dividing. Negative 27, a to the 11th, b to the 10th. Okay, and we got a cube out here, so we're doing cube roots. So first thing I want to do is split them all up into numbers and letters. So negative 27, the cube root of a to the 11th, and then the cube root of b to the 10th. What you want to do for the number is, because 27 is actually a perfect cube, we can just take the cube root of this. It's negative 3, right? So yay, that one's quick. For 8 to the 11th, though, what we want to do is take this power and divide it by that root number. So if we go off to the side and say, how many times does 3 go into 11? Well, that's 3 times. Divide, subtract, divide, multiply, subtract, bring down. Remember all that stuff? So what this does is it creates 3 with a remainder of 2. And yeah, I'm using remainder instead of the fraction, if that's okay with you. So what this does is this tells me the outside power, and this tells me the inside power. And that's a trick, you know. So what I would do, I would write this as a to the third, because of this, not because of this. And then I'll write the cube root of a to the second, inside power. So yeah, it gets a little confusing because you have a 3 power and a 3 root, and they're really close to each other. But please, if you want to, put a little parentheses, and that will keep them separate. Okay, same thing for this. So 3 into 10, again, 3 times, multiply, subtract, remainder of 1. So outside power for b is 3, and then we have a cube root, and then the inside power is 1. Okay? And again, if you have a problem, put it in parentheses. And then anything on the outside can get put together. So 3, a to the third, b to the third. That's all 3 outside things. And then we'll do the cube root of a squared and b, because those are the things on the inside. So if you go back and look at that other problem, 8 divided by 2 is 4, nothing left over. 11 divided by 2 is 5 with 1 left over. So that trick works for this as well. Let's see, I think one more of those. 7th root of y to the 17. So there's only one thing, nothing to split up. So we're going to say 7 into 17, that's 2. And then that's 14 when I multiply. Subtract is 3, so it's a remainder of 3. So the outside power is 2, so I say y squared. And then I say the 7th root of y to the third, the inside power. Done, right? Nice. Okay. Number 10 asks you to multiply them and then break them back apart in the right way. So what somebody did, like with this one, they said square root of 15 times square root of 5. And you're like, no, see, neither of these are perfect squares, so I can't simplify this. So you're going to multiply them back together and get square root of 75. And then you're going to think about numbers that go into 75, like, let's see, 2, no, 3 and 25. Hey, that's a pretty big one. So square root of 25 and square root of 3 is what you'll split them up as. So put them together and then break them apart again, and you get 5 square roots of 3. That's the idea behind 10 and 11 and 12. So 11 is we have 20x square root, and then the square root of 4x. And again, this is a perfect square, but this guy would have to be simplified, and we could go that route, but it's going to be complicated. Instead, it'll be much quicker if we just put these together by multiplying. 20 times 4 is 80. X times x is x squared. See? And now we can split those up. Square root of 80, square root of x squared. Okay. Square root of 80, we think about numbers that multiply to give me 80. So I go, okay, 2 and 40? No. 3? No. 4 and 20? Yeah, hey, but that's how they did it before, so there must be something wrong with it. It's probably not the biggest perfect square. So let's keep going. 5 and 16, I think. Yeah. Oop, that's a perfect square, and it's a big one. I'm going to go with that. 16 and 5. And then this guy, I'm going to leave him alone because I didn't deal with him. I just dealt with him. I'm drawing these little arrows to show where they are going, you know, how they line up. This becomes 4. This is square root of 5. And this guy is the absolute value of x, remember? And again, I'm not that big of a deal. It's not that big of a deal if you forget the absolute value. But I put the outside stuff together and put the inside stuff last, and it looks real pretty. All right? Last one. Is this the last one? Yeah. Last one. Number 12. So we got the square root of 24xy, and we got the square root of 4xy squared. So yes, just like the last two, we multiply them together. We get square root of 24 times 4 is 96. And did I do 96 earlier? Yes, I did. Look at that, number 6. Number 6. He split up into 16 and 6. That's good to know. That way I don't have to like reinvent that problem. And then x times x is x squared. Y times y squared is y to the third. Okay, so that's putting it all together. And then I'm going to split up 96 into 16 and 6 because I saw that in number 6. And then we have x squared. And then we have y to the third, like so. And then for each one of these, 16 is 4, right? Not 8. Don't. So he becomes 4. And then he becomes the absolute value of x. And this guy, okay, so this guy has a number bigger than the square root. So we can say 2 into 3 goes 1 time. And then we subtract 1, we get a remainder of 1. So 1 on the outside, and then 1 on the inside as powers, which I don't have to write ones. Okay, so that's what he becomes. Now I want to put it all together, all the outside stuff. We have him, him, and him. So we have 4xy, and yes, absolute value, but I don't care. And then square root of 6 and square root of y go together. There you go. And if you really want to write, there you go. All right, we'll see you for the next one.